So this is an anticlimactic announcement. The exits are obviously down here to the left. If you bring trash in with you, please take the trash out with you. The trash is at the left of the entrance. We have overflow theaters in 23, 24, 25, and 26. So if you don't find a seat in here, you can't sit in the aisles, go to one of the overflow theaters. As usual, if you have any questions, you can post in Slack or you can ask the speaker directly. Thank you.
All right, hello and welcome. My name is Ed Charbeneau. I'm a principal developer advocate for Progress Software. I am currently focused on the Telerik UI for Blazor. I'm a 6-time Microsoft MVP and also a 6-time Star Trek speaker. I'm an absolute huge Star Trek fan. So I'm happy to be here again speaking to all of you. I do zoom in and out of things on my presentation from time to time. I just wanted to throw up a little warning to folks that may have issues with those sort of things. So just a little friendly reminder that this is going to happen. So today I'm going to help you all and my friend Stephen Strange learn a little bit about Blazor Hybrid and Blazor on the desktop. And we're going to start with Blazor WebAssembly and talk a little bit about responsive web design. And then we'll move on to progressive web applications, or PWAs, to enhance our applications to get them on the desktop using PWA technologies. And then we'll move on to Blazor on Electron and see how that can help us enable our apps to run on the desktop. And then finally, we'll talk about Blazor Hybrid. This is a pattern that uses the new .NET MAUI to get our applications on multiple platforms. So, Stephen, are you ready, sir?
Saved half the universe together. I think we're beyond you calling me sir.
Saved half the universe together. You debugged this guy's JavaScript one time. He thinks you're a hero. All right. We're going to talk about multi-platform madness here. We've got the browser as a platform, the desktop, Windows, iOS or Mac OS, and Android. And we're going to talk about how we can deploy to all of those things. First up, we're going to talk about Blazor WebAssembly and responsive web design, how that can help us. The first thing that we need to do is learn a little bit about Blazor. What exactly is that? Let's have a quick refresher. So Blazor is a single-page application framework by Microsoft that runs .NET. And in a normal web browser, we typically use JavaScript. And that JavaScript gets parsed, compiled, turned into an abstract syntax tree. All of that stuff eventually ends up as bytecode. And that bytecode interacts with the DOM calling APIs in the browser. Now, WebAssemblies come along, and this has given us a direct interface into that bytecode portion of the browser. So we no longer need to send that JavaScript file in and have it do all that compilation inside of the browser. We can do compilation outside of the browser with other languages. So we can use things like C++ and compile code in our other languages to something the web browser understands natively. And that's what Microsoft has done with Blazor. So they've compiled the .NET framework so it runs in the browser. That .NET framework runs our compiled .NET code, and it's using that WebAssembly-based runtime to run our .NET applications in the browser using this web framework called Blazor. Now, the web performance of WebAssembly, when we're talking about Blazor and the .NET context here, the runtime itself is compiled to WebAssembly, not your .NET application. There are options to compile your .NET code into WebAssembly, but that's generally not how it's done. The reason it's done this way is for development time speed. Now, the result of this is it works similar to the way it does as a desktop Common Language Runtime, or CLR. But the key difference is the desktop CLR uses JIT compiling, or just-in-time compilation. And that makes the desktop execute this type of code much faster. So we are talking about code running slower in the browser because we're using .NET. Now, don't count out the Blazor framework just because it sounds like it may be slow because of this. It is not. When you're doing things like web UI, you're just generally changing something on the screen. There's more than enough performance there to make nice web UI for your application. If you're doing something that is CPU intensive, then you're probably going to want to do that on the server and then consume that process from your web application. So if you're building like a PDF on the fly, probably don't want to do that on the local browser. You want to put that in the server and call for the results from the server. So that's where we see the performance kind of trade-off with Blazor. And when we're talking about building web UIs, we want to do this with responsive web technology. So we want to use CSS media queries, flexible content, that sort of thing, because we want our application to work on multiple devices using a single web UI code base. And we can do this right now with modern CSS techniques. This is an example of a demo app that I wrote called Blazport, and it works perfectly well across all devices. You can see we have web, desktop, and mobile here. So with that, what's missing? Well, we're inside of the browser still. We haven't really deployed anything to the desktop. We can't publish this to an app store, it's just a website. We don't get a desktop or home screen icon. These are nice things to have. You get in the store, you can charge money for your app, it's more discoverable, that sort of thing. We also get access to, or we're missing access to device hardware APIs. So if we want to use camera on the device, geolocation, things like that, we have access to it, but it's not the platform's APIs we're calling, it's the web browser's APIs. And then we have the interpreted mode that we're running in with Blazor WebAssembly, so we don't have the full runtime performance here. So let's talk about Blazor and a progressive web application and see if this solves some more of our problems. So what exactly is a progressive web application? It's basically a web app with some extra technology tacked on. So we've got service workers, which we'll talk a little bit more in detail about. These are going to help us make our web application a little more desktop-like. These require a manifest file. A manifest file is basically a file that tells the application where to find icons and other static resources and tells it about service workers. Combining these technologies, we can get on par with platform apps. And again, why we want to do this, we want to make this installable, right? Well, you can install progressive web applications onto your devices. You can also get these in some of the app stores as well. So you can submit PWAs to the iOS or the Apple Store, the Windows Store, and even the Meta Store. So you can throw your 2D web application inside of your VR headset, which is pretty interesting. The requirements for this type of an application is that it has to have a web manifest file, and it has to have the correct fields filled in. Now, we also have to have this as a secure application. It has to be served through HTTPS. We need icons because we're going to be installing this. We need the home icons or desktop icons. Those have to be present in the application. And then we have to have a service worker registered for the app to work offline. Now, this is a requirement by Chrome on Android right now. At the very basics, you could use a service worker that tells your app that it doesn't really have an offline mode and handle that gracefully when the app goes offline, and that is sufficient to meet that requirement. A little bit more about service workers, that they're JavaScript. So we're going to have to use JavaScript. Part of the point of using Blazor, so we can try to avoid some of the JavaScript, So there's a little bit of a trade-off here that if we want to do PWAs and work with this service worker thread, we're going to have to write some JavaScript interop. Generally, the service worker is there to support getting and setting cache when the application is in offline mode. It can also run threads in the background to deliver push notifications. And all of these things are used to make the application a little bit more platform-like. So your desktop-like application or mobile application. And a really good place to go look at what this is capable of is a website by Mozilla called What PWA Can Do Today, .today, that's the domain. And you can try out this installable application that has all of these rich API features. So we're talking about being able to do things in our web app like authentication, Bluetooth, NFC, and generally the device will transition you over to a native UI when it's doing these things. And it's really cool, and you can get pretty close, I like to say platform-like here, to the actual thing. And again, JavaScript is required to do this. So let's take a look at what building a PWA application entails. So we're going to do a quick demo here. We're going to jump into Visual Studio, and we're going to create a brand new Blazor application. So I'm going to click New Project. We'll go ahead and select a Blazor WebAssembly application template from the menu here. And we're going to go ahead and give this a simple name. And the important thing here is that we check the correct template for this application. And this is handed to us out of the box by Microsoft. We can say, give me a progressive web application, and it's going to template out the things that we need to build a PWA. So it's super handy, just one checkbox to get started there. So once we do that, the template will generate for us a manifest file. And the manifest file is pretty simple. Again, it's just a bunch of properties and values, and these are things pointing to icons and other resources for our PWA app. And again, this is required for this to be a PWA. One of the main things is those icons there. We need those home screen and desktop icons. And the template will actually generate some placeholders for us as well. The other thing it gives us is some service worker files. There is a kind of a dummy service worker file for working in development mode. You cannot really debug a service worker in dev mode. It has to be in production for you to actually utilize the PWA. There's plenty of documentation up on the official Microsoft docs on how to do that. And they also supply that production service worker JS file for us that is pre-configured with the things that we're going to need to write those service workers. So we have both of those things at our disposal, but again, this is all in JavaScript. So once we have that application built, we can go ahead and run it, and you'll see that we have some additional features in our application that we didn't have before. One of those things is that we can go up to the browser and say, install that application. When we hit install, it's going to actually drop the Chrome around the browser and treat it more like a desktop app. Once we do that, we have like the preview window that comes up in the taskbar. We can pin it to the taskbar, those sort of things. We can even uninstall the application from this location here or the menu system from within Windows. Before we uninstall, though, I want to show that we can pin it. We can also close the application. And when we close the app, we still have an icon that we can reload the application from. So that's a nice experience that you don't normally get with just a typical website. And then we can uninstall the app as well. So PWA gets us a couple more things. I wonder what my friend Steven thinks.
Weird, but I'll allow it.
It's a little weird, but some of the menus are in different spots than we'd consider from like a traditional desktop app, that sort of thing. But we can publish these things to app stores. And it does give us some desktop and home icons. And it can do some limited device API access and that sort of thing. It's still running Blazor WebAssembly, so it's not getting the full speed of the platform. And some of those publishing to App Store features might vary from vendor to vendor. So I think Mac is a little more, or Apple's a little more strict on what they allow in their marketplace. So you might run into some speed bumps there. So let's talk a little bit about Blazor on Electron and electron.net. So this is going to give us desktop applications using Blazor. So let's talk a little bit about Electron first. What exactly is it? It's a cross-platform desktop app framework that is used to build desktop applications with JavaScript, HTML, and CSS. And it's built quite a few applications that you've probably used. One of the things that probably resonates with this audience is Visual Studio Code. I'm pretty sure almost everybody in here has touched that at some point. Maybe you've been using Teams at work, that sort of stuff. Those are all Electron apps. So what exactly is Electron? Electron is this wrapper that includes a node process. So it's running Node.js, and this Node.js process has access to the operating system's APIs. It also draws a platform UI that gives us our window on top of the Mac or Windows operating system. There's also render processes that are running within the shell here that are using Chromium. So we have a browser wrapped up with Node.js inside of this Electron shell. This is nice, but this requires JavaScript, and I'm trying to stay away from that. I'm a .NET developer. So there's a project out there called electron.net. Now, electron.net is an Electron app that has a .NET Core host inside. So now I have my Electron app, I have my node process, I have my render process with Chrome that I can run Blazor applications from, but I also have a .NET Core process, and this is a full .NET Core process. That .NET Core process has access to the native .NET compiled runtime, so no more WebAssembly. In order to access that, we can run Blazor Server from within the Electron.net app. It's pretty neat. Now, when we do this, you might think it's pretty difficult to set up. You saw the block diagrams there. It seems a little clunky and difficult process to get together. But it's actually not that difficult, so we'll run through that real quick. The first thing we want to do is create a new Blazor Server application. Because remember, we're not going to need WebAssembly here. We have the full .NET Core runtime there that we can run ASP.NET from. So we're going to select Blazor Server there. We'll give this a quick name, create our new project here. And when we create this project, we're going to choose .NET 5, because currently Electron.net only supports .NET 5. They're working on .NET 6 now. We have 7 coming up soon, so hopefully they'll transition to that shortly. So far, we've just got a standard Blazor Server application. We'll go ahead and run this just to see what it looks like. It looks like your basic Hello World application. Notice we're in the browser. There's no desktop-like features here yet. We're just in the Chrome browser. So we'll go ahead and close out of this app, and we'll enable the Electron app. So we need to go into dependencies here and add a few things. Now we're going to go into NuGet Package Manager to search for our Electron APIs and install the Electron API package. So there we've got Electron.net API. We'll go ahead and install that guy. And we also have an Electron.net CLI package that's installed at the command line. I've already done that in advance. That's a global tool for working with these type of applications. So I've got that on the system. That's going to let me run a simple command here at the end of the process, and I'll explain more what that does when we get to it. It's also worth mentioning that that's free and open source, the Electron.net framework. And then once we have the APIs installed, we want to open our program CS file. So we'll jump into program CS, and we'll add to our web builder the required Electron bits. So we'll tell our application that we're going to use Electron. We'll drop in a using statement there so it knows where to find the scope of those dependencies. And then we'll move on to our startup CS file. And in startup CS, we're going to add some services that Electron needs inside of our application. So we'll add to the service pipeline, add Electron. We'll drop in our using statement there, make sure everything's working in the file. And then at the end here, we're going to configure the application. So we're going to add a task here at the end of the configure step that says task.run. We're going to say Electron window manager, create a window async. That's going to spin up that Electron shell for our application. So we're keeping all of the Blazor server stuff there. We're just adding on this extra bit that says, all right, we're going to spin up the shell that the app's going to load inside of. And then finally, in the command line, we're going to run the electronize.init command. That's our global tool that I installed ahead of time. That's going to reconfigure the project as an Electron.net application. It adds dependencies for NPM and those sort of things. So it's basically dropping a config file in our program. So once we do that, Visual Studio will actually recognize that this is an Electron application. We can just hit run from Visual Studio, and instead of popping into the browser, it's actually going to load up that Electron app. And you can see in the background here as it loads up that we're running an npm install, and it's going to get all of the node dependencies that it needs to run that Node.js process. And then inside of a UI shell, there's our Blazor application. Pretty cool. We've got our counter fetch data components that we get with our Hello World project, that sort of thing, but now it's in an actual desktop application. And we even get some menu, platform menu items out of that as well that we can control through our code. All right, so we'll close that guy down, and we'll go ahead and add some things to this project that we can't do with just typical web Blazor applications. Let's go ahead and access the file system. That's something we can't do in a web application. So we'll get rid of some of the boilerplate code here, and we'll drop in a couple using statements. So inside here, we're going to say using, we're going to add file IO, Electron, the Electron namespaces, and so on. There we are. So system.io, electron.net API, Electron entities, and then we can add a code block here to support any of the code that we need for this file. So we'll drop in a Blazor code block. Then we'll need some UI to display our file names. So in here, we're just going to add an unordered list, and we'll for each over the files that we're going to retrieve in our code block. And notice I'm using path get file name to strip off the file path here, and that's part of system.io. So this is all just .NET code so far. Nothing special or JavaScript related. Inside of the code block here on the initialize, I've added some code. We're going to new up an empty array that's going to contain our files. In the initialize method, we're going to go ahead and call on Electron. And what Electron's going to do is get the paths on that device. So we'll say Electron app get paths async. And then we'll pass it a special enumerator of path.name documents. The reason I'm using an enumerator here and not just putting a string in is platform to platform, those folders might be differently named. So this is going to help us make a common reference to a documents folder. Now I can call directory get files. This is part of system.io again, and just grab the files from that path. And once I have that code in place, I can run the application again. And when I run the app and it initializes, it's going to grab the files from my disk. So I have disk access, file IO, right here from a Blazor application using a web UI, which is super convenient for me because I'm a web developer. So there we go, there's our hello world, and there's all the files from my My Documents folder. If I ran this on a Mac, it would find a different Documents folder and display those files in the application. Pretty cool. What do you think, Dr. Strange?
I'll be damned.
I'll be damned, all right. It was a lot easier to set up than I imagined. Like, I thought I was going to have to, like, connect all these weird things together to come up with this, and here it's just add a couple lines of code. And with that, I can publish to app stores. I have a desktop's logo, icon. I have device and hardware API access through electron.net. I have the full speed of the .NET runtime because it's running all of .NET Core inside of that Electron app. What's wrong here, though, is it's desktop only. There are ways to get this published into a mobile app, but from everything that I've read, this is not the best way forward. Electron can be memory intensive, and this is going to eat your battery on your client's devices. You're going to have unhappy customers from what I've heard. So I'd say no on the iOS and Android dev. And then the ecosystem is a little niche here. So there might be a lot of Electron developers out there, Node developers, .NET developers, not a lot of people combining these things together. You're not going to see a lot of blogs about this. The documentation is sparse. Enterprise support's going to be, looking for consultancies, things like that. So things are not perfect here. So let's talk a little bit about something that might give us some more of those features with a little less trade-off. So let's talk about .NET or a Blazor Hybrid on .NET MAUI. So what exactly is .NET MAUI? Let's start there. .NET MAUI is multi-platform app UI. That's where the name MAUI comes from. And it's a cross-platform framework, which is the successor to Xamarin. So if you've ever touched Xamarin before, heard of Xamarin, it's been a very big success for Microsoft. So they're expanding Xamarin beyond mobile onto desktop. And we can use a single shared code base for this to write desktop and mobile applications. And my friend Sam Basu is going to be talking about this at 3:30 in his session. He's going to dive a little bit more into MAUI. MAUI uses XAML technology. I'm a web developer, so XAML, if that scares you like it does me, I'd rather use some web code to do my development. So we have our desktop and mobile with MAUI, Windows, iOS, Mac, and Android. Web's not there. What can we do for the web? Well, with MAUI comes a WebView 2 component or control. And what WebView 2 is an embedded edge browser. So this is an embedded edge browser technology inside of the WebView control, and it lets us render web content inside of platform apps. What's nice about WebView 2 is I can wrap the entire application with this and give control over to all web UI components, or I can mix and match this with the XAML components and render native UI components alongside my web UI components, so I can mix and match. Maybe this is a nice migration path for some of you. Another upside of this WebView technology is there's been similar things in the past. I can already kind of feel some of you going, yeah, I've heard of these embedded web browser things before, and they always get out of date and things like that. Well, with WebView 2, we have evergreen distribution, or you can also choose a fixed version. The fixed version is usually the one that got us in trouble. The evergreen means if there's a new version of Edge, then your WebView 2 also gets updated to that new version of Edge. So you can continue with modern CSS and HTML standards, and your application's going to evolve with those web standards. There's also support for Windows 7 that is not exclusive to MAUI, so you can add this WebView component to existing WPF applications and help migrate those WPF applications to something more modern. So this is technically what a Blazor Web Hybrid application looks like. We have our MAUI app. That's basically a native shell for our application. And then we have our WebView 2 component inside that's hosting our Blazor app. And with that comes the platform APIs. So just like Electron, MAUI has access to quite a few platform APIs. Through MAUI Essentials, we can do all sorts of things. So again, this is accessing hardware on our devices. So we get file pickers, all of the sensors and all of those things that have APIs, we can access all of that. Even things like SMS and text-to-speech, there's too much to even go into here. All right, so let's do a Blazor Hybrid demo now. So keep in mind this is still in preview. So you're going to be on Visual Studio 2022 preview. The templates are still in preview. We expect this to launch very soon. So we're going to pick the .NET MAUI Blazor app preview template. As the name suggests, some things may change over time. Apologize, this is getting out of sync on me. There we go. So we're going to select that preview. We're going to new up a MAUI application. And you're going to see a lot of familiar things to Blazor here because it's essentially a Blazor application. We'll go ahead and name this project. We'll new this guy up. And we'll explore some of the file folders and things that are in there. And you'll notice that there is a lot of Blazor-like stuff in here. So we have our index.razor page. We also have a lot of other familiar things. Pages, shared, www-root. So let's dive into some of those. We have our counter component fetch data. This is exactly like the Hello World app that we get with Blazor WebAssembly and Blazor Server, but it's running inside of a MAUI shell. So we have our shared with our menus, nav bars, all of that sort of thing you should be familiar with if you've ever touched Blazor. We've got a www-root folder because it's a web application. It has our CSS, our HTML index file that boots up the application. The index HTML file here is a little bit more specialized. I'll show this in another demo. We're actually using a different version of the bootstrapper here. So you'll see we have Blazor WebView.js here. If you've ever done any Blazor before, you're used to seeing Blazor.webassembly.js or Blazor.server.js. These are the bootstrappers for Blazor, and in this scenario, we're using Blazor.webview, which is going to give us access to the full .NET runtime capabilities. So we're not running in WebAssembly inside of a MAUI app. All right, next is our app.xaml. App.xaml is the entry point for the UI for the MAUI application. So there is a little bit of XAML in here, but you're not going to really need to touch this. This is just spinning up the application for that platform. And then inside of the initial page, we have some more XAML, but immediately inside of that content page, we have the Blazor WebView. This is our WebView 2 component. The Blazor WebView is a specialized WebView 2 that's meant for hosting Blazor applications. And with the Blazor WebView, we have some properties that we can set. So we have our host page, which tells the WebView how to boot that Blazor application. So this points to our index.html page inside of our www-root folder. We also have a component type property that we can set. The component type says, give us the main.razor file. That's our main component for the application. And this would normally be in a Blazor application, the app.razor file. And this has our routes for the application. So now we're just routing the entire Maui application through Blazor and including all of the pages that the Blazor application has. So you've essentially given control of this Maui app over to Blazor to handle all of the UI. Now you can mix and match that as much as you want. You can add multiple WebView components and display individual components, because that component type we can target. If we want to just render the counter, we could just replace main with counter and render that. So we can mix and match those. We could add more XAML to this and do as much of that combination as we'd like. Next, we've got the platforms folder. This is unique to a Maui application. So inside of the platforms folder, you'll find code that's unique to those platforms. If you need to do anything that's specialized for a particular platform, you could add that code there and create alternate code path for something that needs to happen on Android, whether it's just resources that are required for that platform or something specific code-wise that you need to run. So we have all of our platforms inside of that platforms folder. And Visual Studio is pretty smart here, and it knows what platforms are supported by this Maui app. Currently, I'm on a Pixel 5 emulator, so if I ran the application, I would launch in a Pixel 5 emulator. But in Visual Studio here, I also have the option to run on iOS local devices, Windows machines, that sort of thing. If you're going to build and deploy to an iOS device, you do need Apple hardware on your network. You can remote compile from that hardware that's on your network, but this is an Apple thing. You do need Apple hardware to compile Apple apps. So this is at no fault of Visual Studio, Microsoft, or Maui that you need this extra equipment. But if you want to run these things on all devices, you're going to need some Apple hardware. All right. So let's go ahead and launch this application into an Android emulator. So we'll get to see a Blazor application running inside of our Android environment. So we'll boot up the the Maui app, the Blazor Hybrid application, and you can see that we have our Hello World app right here inside of Android. And this is not running inside of Chrome, it's running inside of the native Android application inside of that web view. And you can see we have our fetch data components, those sort of things that you'd expect from the Blazor templates. And this is truly a native application here, so we get features from the platform as well, like we could just swipe up to dismiss this. It has a home screen icon, so it's a real Android application. You'll see that I've got many icons up here on the desktop where I've tried this a couple different times. Typical developer environment there. But that just shows, we have this installable aspect of our application on Android. Okay, so we have it running on Android. This is not like a PWA. This is actually built into an APK file on Android. It's built into an IPA for iOS, and that gives us the ability to deploy there. And now that we've seen it on Android, let's go ahead and switch to Windows. But before we go ahead and actually switch over and run the application in Windows, we're going to add some more code here. We'll do what we did like we did with the Electron demo. And we'll add some more code here to read from the file system. That's an easy win to show that we're actually accessing some of the native platform APIs. So once again, we'll just drop in a using statement for system IO. We don't need anything else here. We needed just a few more lines in the Electron code. We'll create a code block and the same exact UI that we used for the Electron app. So we're just going to drop in an unordered list. We'll for each over the files that we get. And we'll use system.io to strip off the long path names. And then we'll create some code inside of our code block to go ahead and get those files from disk. So we'll new up an empty array of file names. And then, similar to how we did in the Electron app, we'll use environment get folder path, and then use the enumerator from Maui to get the folder name for us. Because again, these things are going to be different depending on where we run. My Documents is going to be called something different from Windows to Mac to iOS to Android. So we don't want to have to put a bunch of little strings in here to figure all that out. These enumerators help this normalize this for us. And you'll find a lot of that in the APIs for Maui. There's a lot of things that get normalized, so we don't have to write platform-specific code. So once we get that file name, we can initialize the page. And something that's a little bit different here than our Electron app is the fact that if we're on Android, I don't have any files on the emulator. So if I'm on my desktop, I got plenty of files to read from that My Documents folder. On an Android device, the applications are sandboxed. So it's going to go to a sandboxed documents folder for that application. I don't have any files in there, so I'm going to go ahead and create one. So I'll just drop a text file in there, just so I have something to read back. Otherwise, there wouldn't be anything to get. So we'll go ahead and create a file there when the app initializes, and then we'll call directory get files, read the documents back, read the file names back from that documents folder, and then we can display that in our UI. So go ahead and run the application again, and this time we'll have some files coming off disk. And in doing this, we used all .NET APIs to go ahead and write this file and then grab it back from the device's memory. It's a file on that device inside of its sandboxed folder. So it's important to remember these things are sandboxed, especially if you're a web developer like me. We're not used to, we're used to sandboxes in the browser, but not on the actual desktop system. So you got to remember that these things are isolated like that. So we'll go ahead and change this over to run on Windows. We saw that running on Android. Just by switching the drop-down there and hitting play on Windows, this will actually load up inside of a Windows application. So this is going to be running on the Windows runtime, right on the desktop. And you'll notice that when the application loads, it's the same list of files as before when we ran the Electron app. It's reading right from that My Documents folder and getting all of those things. So I ran it on Android and on Windows, the same code, the same UI, to get those files and display those files with no changes, just telling the compiler that we were running on one device or another. Okay. So what do you think, Dr. Strange?
Anyway.
Yeah, he's ready. Are you ready? You ready to run some more Blazor Hybrid apps? We've got a little bit more to do here. They're true hybrid applications. Remember, we can mix and match. Just to remember there, we can use platform UI and share state and also have web UI running that shared state. They're also truly hybrid in the sense that we can use web, desktop, and mobile all from one code base. We can actually use web too. We've already built the web application part of it. We can actually pull those resources in fairly easy. So let's demo this one more time with another app. First thing is this project has solution has multiple projects. We have a client project. We have a Maui project. And the Maui project has a dependency on the web UI client project. So we have a Blazor WebAssembly project here, and then the Maui project just has a dependency on that WebAssembly project. And we'll see here in a minute that there's a couple things that differentiate the two. So they can run, if I run the web application, it'll run WebAssembly. If I run the MAUI application, it'll run the full .NET framework. But essentially, they just have one dependency where the MAUI app is getting resources from the Blazor WebAssembly app. We also have a server app. The server app hosts the Blazor WebAssembly application, and it also has web API endpoints for both applications to consume JSON data. At no time does the server serve HTML to the MAUI app. That is not a thing. It's not something we're going to be doing. It serves it data. So it's there to provide data to the MAUI application. We also have a shared folder. Since both of these projects have the same technologies, we can share code among the MAUI app, the server app, and the client UI app running in WebAssembly. That's something pretty unique. Inside of the client app, we have our pages, our www root folder, our shared folder, our components for our application that are all built in Razor. Notice those pages are missing from the MAUI app. They're all in the WebAssembly application. We have a dependency from the MAUI app to the WebAssembly app, so it can find those pages and components and pull them in and use them. I don't have to make a duplicate copy of all those pages and components to use them in my MAUI app. All I have to do is this, check a box, and I can go get those resources. That includes the www root folder as well. So there's a little bit of configuration that needs to happen here. One of the things is in the main Razor file under additional assemblies, we'll just tell it where those resources are located in the dependency that we just referenced. So we'll say on the client app.assembly, use reflection to go find those things. The router will then get all of the routes from any pages inside of that Blazor application. So that's pretty cool. It's the same way that Razor class libraries work, by the way. So this is very standard technique stuff. The next thing that we want to do is tell our web application, or our bootstrapping portion of the application, that we want to use Blazor on MAUI, and I want to compare real quick. The web app uses the script the MAUI app uses blazor.webview.js, and then the HTML from the other application uses blazor.webassembly.js. So we should be able to see that side by side. I think the slide's getting a little cut off here in the room. But essentially, we've got two different index HTML files depending on where the app's being hosted. Also, between the two apps here, their startup files are slightly different. I have in these two program CS files different dependencies through dependency injection. So when I boot up the application in WebAssembly, I'm going to have an iWeather service that resolves to weather service web concrete implementation. On the other application, on MAUI, I have a service specific for MAUI. So I can use dependency injection to swap out some functionality here if I need to. So that's another way that I can do these cross-platform things with a single code base. So I'm going to go ahead and run the server application to make sure that I'm getting any JSON data that needs to be supplied to both applications. And it will also initialize my web application. So I've got my web app. That one says hello from Blazor WebAssembly. That's coming from the dependency injection implementation of a service. It's telling me where it's being hosted, just to kind of show you that we can have alternate code paths there. When I start my Maui application, I'm going to run this one on Windows. And this one's going to run the exact same code base for the UI, just a different shell hosted in Maui. So this one has the full capability of .NET framework. And this one's running from a Maui shell native on the desktop. So the two apps side by side, they're using the same components. All the same pages, same components, different services, if I'd like to. You can use the same services if they don't need any kind of tweaking, but I'm using two different services here, just to show an example. They know where they're running from. One's using WebAssembly, one's using full .NET Runtime. You ready? Ready for that? All right. So I think he's a little more excited than folks that are wanting some lunch today. But what this gives us is almost everything we want, except for Linux. Sorry, Linux. Aw, poor Linux. I heard this is in the works, but it's not currently supported in the current state. So, it's up to you to choose what stack from this you'd like to use, depending on what your needs are. You've got Blazor Hybrid, you've got Blazor Electron, you've got PWAs. Breaking them all down, you get almost everything with Blazor Hybrid. This is going to be the platform forward, in my opinion. Electron has some of its issues. If you need Linux, Electron's your thing, though, currently. If you need to be on like the Quest for some reason, then a PWA is what you need. So there's a few places where these different frameworks can fit into what you need. And I have some resources for you to follow as well. I created like a blog post with just like all the resources in it. So you don't have to...
The internet and Scooby-Doo this shit.
Yeah, you just go to one place and find it. It's much easier that way. So if you just go to my website and hit that URL there, you will find all of the resources for it. We're also at the Progress booth here if you need to follow up on any questions. I'll try to follow up in chat. We don't have time for questions. I do have a little post-credit teaser, though.
Don't cast that spell. It's too dangerous. Why?
We tamper with the stability of space-time. The multiverse is a concept about which we know frighteningly little.
I'm not here to talk about Westview. We need your help.
Actually, sir, I might be able to help. Turns out, in this new multiverse, Blazor isn't just for web anymore. It runs beautifully on mobile or desktop. And I might be able to show you how. So if you can do your magical thing and meet me at the Aware Theater at 3:30 this afternoon, I'd like to show you how.
So my friend Sam is talking about more Blazor Hybrid and Maui and Aware at 3:30. Please go see him. And he's a Mac guy, so you'll see demos running not only coding in a Mac environment, but deploying to Mac environment, just to show you how truly cross-platform this is. Go see him on his take of all this. And he is definitely like a XAML, Xamarin guy as well. So we come from two different types of backgrounds, but we're kind of meeting in the middle and finding different parts of these platforms we really enjoy writing. So thank you all, and make sure you check him out later as well.